Today I will present about the status of my research. So I was doing a research on clustering algorithms, more specifically about hierarchical algorithms. I wanted to drive my research toward predicting the performance of students in high school because there are a lot of papers, a lot of research about this topic, but mostly focus on performing of the students in the university. I guess because the professor who do the research, they are more involved with universities. Since I was trying to cluster students according to their performance, I decided to drive my research in one of the clustering algorithms most used, hierarchical, as I say, no? I read about hierarchical algorithms a lot, but due to a personal issue, I had to stop my research for a while. So now I'm back to my research. And to be honest, I had to review and recap about the clustering algorithms again. So I start again from something basic, the most common clustering algorithms, k-means, hierarchical again, db-scan, GMM. I start understanding the math behind these algorithms because when I read paper, the part where the math comes or about the algorithms, it's hard for me to understand, to be honest. So I wanted to start by understanding the math behind these algorithms. So I start again my research by understanding the math of these algorithms. So reading about these algorithms in website, watching some videos in YouTube, reading some blogs, and also some books, I found a term that repeats a lot: deterministic and stochastic models. So I was curious. So I was trying to understand. I was trying to read like what is this about, no? So reading about these two terms, I found a book, actually two books, and it mentioned and repeated a new term. So this new term was meta-heuristic algorithms, heuristic and meta-heuristic algorithms. So I was curious, what is heuristic and meta-heuristic algorithms? So I start now reading about heuristic and meta-heuristic algorithms. So here is where my new research starts. I start reading more about these two terms, heuristic and meta-heuristic algorithms, and I found this picture in one of the books that I was reading. This book explains really well the difference between these two terms and explain a little about each algorithms, each method here in this picture. Later on, I found this picture in one paper, and so I was so excited because this was what I was looking for. Because Jan before she asked me to search about dragonfly algorithm, and intentionally I found it by reading about meta-heuristic algorithms. I found dragonfly algorithm, so I was kind of like happy, excited, because unintentionally I came to that point. So I want to be able to understand the algorithm that Chan she asked me to read about. So I start reading papers about swarm-based algorithms, as you see here, and I start from PSO, particle swarm optimization. After that, I read about ACO, ants colony optimization, as you can see on the right. And yes, I was reading about this algorithm. I read a lot of papers about these algorithms, to be honest, and I was fascinated. I really like this algorithm because it's easy to understand, it's easy to implement, and there are a lot of research. So I was fascinated. I was happy with these algorithms. So Now I find myself reading, searching about Dragonfly algorithms. Um, as you notice, Dragonfly algorithm was created in 2016, and the ant colony optimization was created in 1998. So I have a question: which one do you think has more research about, the Dragonfly or the ant colony optimization? So yes, of course, seems ant colony optimization is older than Dragonfly. It has more researchers about. But which one do you think is more feasible to improve? So yeah, the easiest to improve is Dragonfly algorithm because there are less research about that, no? So doing my research about Dragonfly algorithm, a Chan asked me to search for the code of this algorithm and trying to play a little with this code and understand the code. So I found one version in GitHub, and I found this code and this paper in a website that I highly recommended, and it's called Paper with Code. So this website provides the paper and code, so those who wants to work with both at the same time to understand better the paper and the code is a good idea. So I found this paper about Dragonfly, and it provides the paper as well. And as you can see, this paper is from 2019. It's pretty new if we compare with other papers. And to be honest, this paper is in Python, and I feel comfortable working with Python. The problem of this code is the version of this paper is new. It's a new research. So the code is not the original code. It's not the first version of the code. It's a little longer, no? So I tried to search and search for the first paper about Dragonfly. It was not easy, but I got it. I found it. This is the first paper about Dragonfly algorithm, and his author, as many researchers, they have their own website. So this author has his own website where he posts uh, different versions of his code in MATLAB. Um, MATLAB is a new language for me, but the version of this code is much easier than the version of this code. Much easier than this code, because this one is from a research of 2019, and this code is from a research of 2016, and is the first version, so it's even easier to understand. So right now I'm understanding and using this code, this version, to implement in my research. As you know, to continue, as you know, there are many research that sometimes they review what people have been doing for the last 10 years, for example, no? So I found a paper about Dragonfly algorithm where where the paper explained what people have been doing the last years. Of course, it's a new algorithm from 2016, so it explained what people have been doing from 2016 until 2020. So it was good because first explain the algorithm very good and easy. Second, it talks about what people have been doing. And third, it says, besides merging new searching methods with Dragonfly is highly recommended. You see, highly recommended. Why? Because this algorithm is powerful, and if we we merge with other algorithms, becomes more powerful. And this is my thesis about. My thesis is about a new method to merge by using Dragonfly algorithms and a clustering algorithm to solve a clustering problem. Why clustering? Because as you remember, first I start my thesis researching about clustering. To be precise, I was searching about hierarchical clustering. So this new algorithm has been implemented with different methods like k-mean, but there is a method that I found that, or I didn't find, that people has implement Dragonfly algorithm with this method, and it's called k-medoid. So the difference between k-mean and k-medoid is that in k-means we choose a random centroid. However, in the another method we choose a point, one of the points that we need to cluster is choosing as a centroid. That is the big difference between these two methods, no? Yes, so I right now I'm trying to search if someone already implement these two methods together, and I have not find. This is just a joke. Of course, I don't search like that in Google, but yes, what I have been searching in different websites of research, I have not find someone who has implemented these two methods together. So right now I'm reading about Dragonfly, playing with its code, searching methods to hybridize the Dragonfly algorithm with other algorithms, and also I'm searching for some papers about Dragonfly algorithms in clustering problems, because that is my research about. So there are two ways to implement this hybrid idea, and is, of first, I find a problem where people has not implement these two algorithms together. So this is the first option. I find the problem to implement the hybrid algorithm of Dragonfly plus k-medoid. And the second option, that is the one that I will take, is I stick with the traditional algorithms, Dragonfly and k-medoid, and I try to modify both of them in order to implement them and solve one clustering algorithm, one clustering problem where people where people has not used these two methods to solve this clustering problem. So right now I'm playing with the code of MATLAB to understand the algorithms and see how can I improve the method. Second, I'm searching for methods to hybridize my Dragonfly algorithm with k-medoid. And third, I'm finding the problem where I can apply these two methods in order to solve a clustering problem. So these three things are what I'm doing right now, and I hope everyone is doing good in your research, and thank you so much.